All right, so first one, which of the following functions are continuous at 1? The first one is just ln of x, and I would kind of just think about what that graph looks like. And this is why we went over graphing these functions. Ln of x is going to have the vertical asymptote here, and then do something like this. So at 1, which is right here, that function is continuous. I realize there's an asymptote here, but it says at x equals 1. So you kind of need to ignore everything else except 1, and you're just zooming in on that 1 point. So that one is good. The second one, e to the x, is the inverse of ln. So it's going to have the horizontal asymptote and do something like this. Here we are at 1. And the function is continuous there. In fact, this function is continuous on all real numbers. So that one is good. And then this one, I don't know what that graph would look like off the top of my head, but what I would do is just try to plug in 1 and see if you get a value. If you get a value, then you're okay. Otherwise, you would have a hole or an asymptote, but I would just try to plug in 1. So e to the 1 would be e, that would be about 2.718, so like 2.7-ish. Minus 1 would be about 1.7, so this would be like ln of 1.7. And here's our ln graph. If this is 1, 1.7 is going to be like right about here. And we would have a point there. That function would be continuous there. So this one is also good. And so we get e, all 3 of them. Again, I'm going to go through all 10 of the homework problems. I hope that you have whatever you wrote for yours out and you're checking it as we go along. Just jump in here if you have a question as I'm going through. All right, this one says, graph of a function f is shown. Which of the following statements is false? So we're going to go through and decide true or false for each of these, and we want to pick the one that's false. So f is continuous at a. What do you think? Is this function continuous at a? You can just type yes or no in the chat. Are we continuous at a? Good. No, we are not continuous at a, so that is false. And we were looking for the one that's false, so that's actually going to be the answer. We found it on the first try, but let me just go through the other choices. Just for the sake of being thorough here. A relative maximum means the highest point compared to those around it. And the actual point is right here. So that is the highest point compared to all the other points around it. So that's why that is true. X equals a is in the domain. Well, we have a point. It got stolen from the graph and it's up here, but there is a point. So we do have that value in the domain. There is a point there. It's true. If this point was missing, then that would not be true. But it is there. This one says limit as we approach a from the right of this function equals limit as we approach a from the left of this function. And that's true. As we get closer and closer to a, as we zoom in on this point, both sides are going to the same place. You know, let me turn on my light so we've got a little bit more light here. I realize that there's a hole there and then the point's somewhere else, but both sides, if we zoom in, are going to the same place. So that is true. And then the limit as x approaches a exists. Yes, that's true. It would be whatever y value this is right here. Now they didn't label, so I don't know if this is 2 or 3 or 10 billion. You know, I'm not sure because they didn't label, but whatever that y value is what that answer would be. I got a question in the chat. Why is it not considered continuous at a? Let's go back over our 3 rules. The first rule is there has to be a point. It follows that rule. We're good. The second rule is that there has to be a limit, and it also follows that rule. We're good. Both sides go to the same place. So first rule is good. Second rule is good. The third rule is that they are equal, and that's the rule that got broken. These 2 were good. This is the rule that got broken. The point, you know what, let me label this axis so we have some actual numbers to go on. Say this is 1, 2, 3, 4. The limit is at 3, but the actual point is at 4. So we'll say the limit's at 3, but the point's at 4. So they don't equal each other, and that's why it's considered not continuous. All right, number 3. We want the function to be continuous at 3 and then find k. Well, if we want this function to be continuous, what are we going to do with the 2 pieces of the function? You guys can just type in the chat. What are we going to do with those if we want it to meet up? Perfect. Set them equal. All right, so I'm going to have x squared plus 2 equals 6x plus k. Good. And then we're going to plug in 3 for x. So everywhere there's an x, we're going to plug in 3. And then we're going to solve for k. So, oh, I did a copy error there. I'm so sorry. This is a squared. 3 squared would be 9, plus 2 would be 11. Over here, this would be 18 plus k. And then when you subtract the 18, you're going to get negative 7. All right, so next one, graph of a function f is shown. Which statement is true? Okay, that other question we had, which one is false? This time they're asking which is true, but I would still just go through all 5 and treat them all like true, false questions. All right, so f of a equals 2. That's the actual point. The actual point is at 1, so that is false, because f of a actually equals 1 here. F is continuous at A. That is also false. Again, that third rule gets broken. The point is at 1, but the limit is up here at 2. All right, limit as x approaches A equals 1. Well, no, both sides are going to where this hole is, which is at 2. So that is false. This one says that the limit equals 2, which is true. So that's going to be our answer. That's the one we want. But again, I'm going to go through all of them. And then this one says the limit as we approach A does not exist. Well, that's false. We just said that that limit equals 2. I realize there's a hole there, but it doesn't matter. If we zoom in on the point, both sides are going to the same value, which is 2. All right, graph of a function f is shown. Which limit does not exist? All right, so let's just go through all of them and see which ones we can answer and which ones don't exist. Limit is x goes to 1 from the left. So here is 1. If we approach from the left, what are we getting closer and closer to? What y value do we approach at 1? All right, good. That one would be 0. So we got an answer for that one. So it is not, does not exist. All right, limit as x approaches 1, and there's not a plus or minus. That means both sides have to agree. Well, limit as we go to 1 from both sides would still be 0. So we got an answer for that as well. Limit as x goes to 3 from the left. So here's 3, but we only want from the left. So we're just looking at this side. So that would be approaching 2. So we can get an answer for that one as well. This is limit as x approaches 3, and it's not sided. So that means both sides have to agree. Well, if we look at 3, the left side's going to 2, but the right side is going down to negative infinity. So if we try to zoom in on that point, there's no agreement. And so that's the one that does not exist. So that's going to be our answer. But let's look at the last one. And then I get these questions from College Board. They messed up their notation on this one. It should look like this, the way all the rest of them do. Limit as x goes to 5. Here's 5. I realize there's a hole there, but it doesn't matter. Both sides are approaching, what do you want to call that, like 4.7? So we can get an answer for that one as well. So this is the one that does not exist. All right, figure above shows the graph of a function f. That's kind of how all these are starting here. Which of the following statements are true? Well, let's just go through each of them and see if they're true or false. Limit as x approaches 2 from the left of the function equals f of 2. All right, well, let's just do each of those and see if they equal each other. We're approaching 2 from the left. So we want to ignore all of this. We just want to approach 2 from the left. and we are getting closer and closer to -1. So this would be -1. And then f of 2, that's where the actual point is at 2. So here's 2, the actual point is down there at -1. So those are equal, and we're good. This is limit as x approaches 6 from the left of the function, and limit as x approaches 6 from the right of the function. So here's 6. From the left and the right, both sides are approaching -1. So both of those are -1, and so we are good. And then this last one is limit as x approaches 6 overall equals f of 6. Well, we just said the limit as we go to 6 from the left and the right was -1. But where is the actual functional value for 6? What is f of 6 for this graph? Oh, and that's fine, Thomas. I'm glad you were back. And yes, -3 is where that actual point is. So we are not continuous at 6. There is a limit and there is a point, but they don't equal each other. And so this one is false. So our answer would be that we want Roman numeral 1 and 2, which is C. And I'm going to post this video when we're done. So whatever ones you missed, you'll be able to watch them. All right, graph of a function is shown. For which of the following values does the limit as you approach that value on the function equal 1? Well, let's go through and make a list of everything that we've got to check. It looks like we have to check 0 and 3 and -2. And that appears to be it. So we want to see which ones of these does the limit approach 1. So let's look at 0. Here's 0. What do you think? Just type in a yes or a no, guys. Does that limit as we approach 0 of this function equal 1? Yes, good. That one is 1. All right, let's look at 3. What do you guys think? You can just type a yes or no. If we zoom in on 3, does that limit approach 1? And that one's a little tougher, but Abby, you are correct. The answer is no. We don't get a limit at 3. The left side and the right side don't agree with each other. They're not both coming to the same place. So that limit does not exist. So it cannot equal 1 if it does not exist. From the left, it's 1, but from the right, it's not. All right, and then lastly, -2. Guys, look at -2. Does the limit as we approach -2 for this function equal 1? Just give me a yes or a no. Yes, good. That one is a yes. So we want 0 and -2, which is C. All right, graph of a function f is shown. We want the limit as x approaches b of the function to exist. So we want a limit. That means both sides have to come to the same place. We want the limit to exist, but to not be continuous. The way that that happens is with this situation. Both sides come to the same place, but you're not continuous. The point is somewhere else. Or I guess you don't even have to have a point somewhere else. You can have a limit and then just have a hole. So one of these situations. So where is that happening on this graph? Where do we have something like that, where there's either a hole or there's a hole and the point is somewhere else? Which one of these choices do we have one of those situations going on? Good, yeah, here it's 0. We've got that going on. So B is our answer. Follow-up question. Are these considered removable or non-removable? I'll tell you if you've all forgotten. I just want to see what you guys remember. Would these kind of discontinuities be removable or non-removable? Good. Yes, they are removable. I had a couple people answer removable. You can fix them just by putting the point back. Non-removable is something like a jump. You can't fix that just by putting a point back, or an asymptote. That would be non-removable. Those are bigger problems. You can't fix them as easily. This one, at what value of x do we have a jump discontinuity? So here's where the jump is happening. And so that is at 7. So that one is C. And so again, that's non-removable. And then last one. For which of the following does limit as we approach 4 exist? Not what is it, just does it exist? So for this one, as we zoom in on 4, both sides are coming to the same place. So that one's good. Same thing here, as we approach 4, both sides are coming to the same place. So that one's good. And here we have a jump discontinuity. So the left and the right don't agree with each other. So that limit does not exist. From the left, it exists, and from the right, it exists. But overall, we don't have any agreement. If you try to zoom in on that point, you're not coming all to the same place. So we just want 1 and 2. And so that is D.